Bismillahirrahmanirrahim and welcome to Rahman Digital Production. This is lecture number 10 of Physics 5054 of GCE. We yesterday discussed three of the questions and now we will turn our focus to question number 4. But before understanding the question, let me remind you that subscribe my channel and press the bell icon to support me. Analytics are showing me, which is about my channel, that there are 80% people not subscribed your channel and they are seeing your videos, and only 20% people subscribe the channel and viewing your videos. So this is my request to those people who not yet subscribe my channel. Please subscribe my channel and support me. I will continue with more enthusiasm if you are supporting me. Now let's start the question number 4. And question number 4, A part is saying that what is meant by velocity, number 1 part, and the second one is acceleration. We discussed these velocities and accelerations in greater detail, but to refresh your memory, let me again repeat the definition of velocity. The rate of change of displacements with respect to time is called velocity. In other words, we can say that speed in particular direction is called velocity. Remember that velocity is a vector quantity. It means that it must have a magnitude and it must have a direction. Similarly, acceleration is the rate of change of velocity. If velocity is changing, then it means acceleration is produced. Ladies and gentlemen, I told you that if magnitude is changing, this is called linear acceleration in a particular direction. But if the direction is changing, then it is called angular acceleration. Acceleration is also a vector quantity just like velocity. So, angular velocity is not the topic of interest of us. We will only dealing with the acceleration, linear acceleration. Acceleration can be positive and acceleration can be negative. If the magnitude of velocity is increasing uniformly, then it means that acceleration is increasing. If the velocity is decreasing, then it is called deceleration, retardation, or negative acceleration. These topics has been discussed in the previous lectures. So if you want to get in-depth analysis of this topic, visit my previous lectures and clear your concept. Now the B part of this question is saying, listen carefully, a lift on its upward journey start from rest and accelerates for 5 seconds. It is starting from rest. It means it is starting from zero, and then it is accelerating uniformly to 5 seconds. This is the time shown in seconds, and this is the velocity. The velocity is changing from 0 to 2. It means there is change in the velocity. When there is change in the velocity, it means that there is acceleration. And this acceleration is denoted by this line. Now, until it reaches a velocity of 2 meter per second. So the first line is showing this one. After this, it moves at a constant speed for 10 seconds and then returns to rest after 5 seconds. It means that it is moving with constant speed for 10 seconds. So you don't have to write this 10 seconds. You have to count it from 5 till 15. So 15 minus 5 is equal to 10. So it is constantly moving with for the next, and then retardation has been observed. So it means that it is negative acceleration. That is called retardation for the next 5 seconds, which is from 15 seconds to 20 seconds. The question is saying for its that was for upward journey. That is for upward journey. And now we have to talk about the downward journey. The question is saying for its downward journey, it again start from rest and accelerating for 10 seconds until it reaches a velocity of 3 meter per second. So it is for 10 seconds reaching to 3 meter per second. It is denoted with this red line. Then it retards to rest after another 10 seconds. So on another 10 seconds, it is retarding to this 20. So first 20 seconds is upward and the next 10 seconds are downwards. So the downwards motion in a graphical shape is shown like this, and the upward is shown like this. Now we are saying that the B part, these are the graphs, but we have to derive something from it. The first part in the B section is saying calculate its acceleration during the upward journey. Calculate its acceleration. This is acceleration. No acceleration. This is retardation. So we have to find acceleration in this region. And for that we have to write in the B part one number part is saying find acceleration. So acceleration is rate of change of velocity with respect to time. So rate of change of velocity is from 0 to 2. So it means that it is from final velocity we have to subtract the initial velocity, and then time is 5 seconds. When we calculate it, it will be 2 divided by 5, and 2 divided by 5 is when we divide it, 0.4 meter per second square is the answer. That is the first part. And then they are saying that its retardation during the downward journey, and its retardation during the downward journey. So this is the downward journey, and this is the retardation, and this is the acceleration. So we have to find in this particular area the acceleration. So acceleration in this case is equal to delta V divided by T. In this particular case, the final velocity is 0 and the initial velocity is, you can see that it is 3. So 0 minus 3 and then 10 second is the, from here to here, it is time and it is velocity. So velocity is initial 3, sorry, initial is uh, 3 and final is 0. Yes, so it is equal to minus 3 divided by 10. What the negative sign is showing? It is showing retardation. When we divide this, so we will get 0.3 meter per second square, and that is -1. So it is retardation. Actually, it is showing retardation, the negative acceleration. The third part is saying, what can you say about the areas under the two velocity time graphs? There are first graph upward motion, and there are downward motion. What can you say? The question is saying that what you can say about the areas under the two velocity time graph. So first we have to find the area under this, and then we have to find the area under this graph, and then we will be able to construct an idea about the motion. So let us first find the upward motion of the graph. Okay, let us start first from this figure. There is part number 1, this is part number 2, and this is part number 3. And let us find. For this is part number 3, and area 1 is equal to 1 over 2 into height, which is 2, into base, which is 5. So 2 will be cancelled with this, and that is 5 meter square, which can be written as 5 meter. Area under the graph is the distance. Now A2 is a rectangle. Sometime I am saying to the rectangle as a triangle, and to triangle rectangle. That is not deliberate. So excuse me for that. In one of the previous lectures, I saw that I told rectangle to the triangle, but the formula is correct. My mind is working correctly, but sometime from the mouth the words comes out. For that I am seeking your apology. Okay, this is area 2 and that is the length, which is 15, because 20 minus 5 of this rectangle, and then 2 is the height, so it means 30 meter square, which is 30 meter. Now A3, we are going to find area of 3 and that is 1 over 2 into 2 into 5, and 2 will be cancelled with this, so 5 meter square, then it is equal to 5 meter. So total area under the graph is equal to 5 plus 30 plus 5. So it means that it is 40 meter, and that is the case with the upward motion. Now ladies and gentlemen, let us talk about the downward motion. There are two triangle, one is this one and one is this one. So here in this case, area 1 is equal to 1 over 2 into height. What is the height? That is 3. And what is the uh, base of this? So it means it is 10. 2 ones are 2, 2 fives are 10. So it means 13 meter square, which in other words we can write 13 meter. Now A2 is also the same. So 1 over 2 into 3 into 10, again 2 will be cancelled with this 10. So it is, now this is 15 not 13, and that is also 15 meter, which is equal to what? That is equal to 15 meter. This is also 15 meter. So in case of the total area is equal to 15 plus 15, which is equal to 30 meter square, which is equal to 30 meter. Ladies and gentlemen, here we are saying that 1 over 2, this is the 10 not 15, because you can see it from here to here. I was thinking till here, but this is 10 and that will be equal to then 20, and then if here is 20, so it will also be 30 meters. So in both upward and downward motion, the area under the graph is the same. So it is evident from the graph, from the calculation, that in upward and downward motions, the left covered the same distance. Yes, this is our observation and we proved it from the calculations. Now, that was the whole story about question number 4. Now, we will turn our focus to question number 5. Let us first understand question number 5 and then we will solve the question number 5. Okay, let us first understand the question number 5, and that is a feather is allowed to be released from rest in two different environments. In one without air, that is vacuum, and then in the presence of air. So I made these graphs for you people. This is in vacuum because there is no air resistance there. So it will increase uniformly and there will be constant acceleration. We discussed these in greater detail in the previous lecture, but here for your memory refreshment, I did it again. If there is air resistance, let me tell you that there is an object which is feather, and let us consider that as feather. For example, this is a feather, and when it start downwards motion, there will be an upward air resistance. But first the air resistance will be less and it will try to equalize the force of gravity. It is increasing because there is air resistance, but at first the weight is more, so till this area it will accelerate, and then the air resistance will try to balance this feather, then it will stop accelerating and it will continue with the constant speed. So I am writing these sentences here, that when the force of air resistance when the force of air resistance equals the gravity, the object then the object stop accelerating and will maintain its constant speed, which can be shown from this part. So first it is accelerating and then constant. Okay, this is velocity time graph for both the cases. If we are having displacement time graph, because it is not shown that discuss it velocity and discuss its velocity and time graph. We are discussing In velocity time graph, we are getting two different lines. But if we are discussing, yeah, explaining this situation of feather in the context of displacement time graph, then it means that we will get this one. And we saw that in the feather and hammer case, that first displacement is small and then the displacement is increasing. Then the displacement is increasing. In this case, first, when there is no vacuum, slowly the displacement is increasing, and here abruptly it is increasing. This displacement. Then we are discussing the acceleration time graph. In vacuum, the acceleration will be constant. In air, the acceleration will be constant. When there is a air resistance, then it will gradually decrease and it will come to zero at rest at this position. So remember, ladies and gentlemen, in case of velocity time graph, we are getting different curves. And in case of displacement time graph, we are getting different curves. And in acceleration time graph, we are getting different curves. So when you are explaining these things, you have to be careful that whether you are explaining in the context of VT, या dt या at graph, acceleration time graph. Okay, that was the second part of question number 5, and that was part number 1. That's it for today. Tomorrow we will discuss more concept and question number 6, which is very important. Don't miss, and try to subscribe my channel and press the bell icon so you will be notified. Thank you for watching. Allah Hafiz.